So here we go. In your notes, you've got some things that have some spaces, so we're starting off with statistics. Science of data, right? Two very exciting words in there, data and science. Data, data, yeah, probably, to pronounce it with an English accent.
Data.
Univariate. So we've got uni, which means one, and variate, which is variable. So it's statistics with a single variable, like the shoe sizes of everybody in class. We've got data that is either qualitative or quantitative. Qualitative data is when you're taking descriptive stuff, like we look at shoes and how many white, how many black. We're describing things. Well, we're still taking numbers there, so we're a bit quantitative, but happy-looking shoes, sad-looking shoes, you need new shoes, things like that would be descriptive stuff. And in quantitative data, your data is either continuous, in which all values are possible, or discrete, which only certain values are possible. And shoe sizes are discrete. You can't go and buy, oh, my shoe size is a 9.738, please. And then they manufacture that perfectly for you, right? Some people have, like, maybe you have feet that no matter where you go, shoes just fit well. And someone else has feet that it's just sort of like, ugh. Sometimes the 9s fit me, sometimes they're too small. Sometimes the 9.5s are perfect, sometimes they're way too big. And I'm in between kind of sizes. So you've got like the 9.258 foot size that just causes you issues depending on the brand. Right? Heights would be continuous. Right? And height is a really good thing. Can you imagine if heights were discrete? And let's say heights were discrete with inches. So when you were growing, you're 5'6", and you would just stay at 5'6", and then all of a sudden one day you'd start to shake a little bit, and then boom, you'd be 5'7". You would never be 5'6.5". You just jump a height. Right? That would be what would happen if heights were discrete. And so it could be dangerous if you were just barely walking through something and you grew that inch at that instant, boom, you'd hit your head and you'd be mad. So certain things have to be continuous, right? But the number of students with smartphones is discrete. You can't have like half a student with a smartphone. I've never used my left hand with my smartphone. It's just the right side of my body. And we can put all of this stuff into our calculator. So our statistics unit is something, or did I skip? I skipped a whole bunch of, there we go, here. But we are going to use our calculator a fair bit. So we've got a population means that we talk about everything, and a sample is just a part of the population. So we can draw a nice diagram showing the population as being the big thing and the sample as just being a part of that. And a lot of times when you want a sample, you want it to be random, because if you get a random sample, then it's more indicative of what the population believes, right? But if you get a non-random sample, then it might be different. For example, if I wanted to know some sort of data from this school, I'm trying to think of a good example, where if I ask the grade 12s only, it'll be skewed, right? If I asked the grade 9s only, it would be skewed. But if I asked a random sample which included 9s, 10s, 11s, and 12s, I would get a better feeling for how the school feels about grade 9s. Yes. Right, if we would do like a qualitative study, right? How did the hallways smell when all the grade 9s came? Right, there might be a different viewpoint if it was just asked the grade 12s compared to the grade 9s. frequency table is an easy way for us to view data, especially when you have data that happens more often. So our first example that we have here, we've got a bunch of data. It's all spread out, and this is typically when you take a survey, you have things not come in order, right? Here a scientist counted fish. Who do you think made this question? For the French immersion people. Yeah, has to do with fish. And you're going to get different data, and they got 10 fish the first day and 10 again on the fourth day, but the data isn't nicely organized. So sometimes what we would do is we would organize the data, and I'm not going to get you to take the time to fill this out because it's really quick, but you would tally things up as you're going. So you go through the list and say, okay, I hit a 10 once, and then I hit a 12, and then afterwards count them, and we've got 3 10s, 3 11s, 4 12s, and so on all the way through. This becomes a frequency table. We have our number of fish in the one column and our frequency right next to it. There's our frequency table, and from that we can create a bar chart showing different heights, 10, 11, and gives us an indication of what has happened. So statistics is about getting data and then also organizing your data so that it's more useful. Both the frequency chart and the bar chart is, to me, much more useful visually than the original set of data. The original set of data just seems like a bunch of numbers all over the place. But when I organize it, it's like, oh, I can see patterns quicker. I can get a better sense quicker of what's happening. Have you ever used the data part of your calculator before? Just trying to see if they take my calculator off of my... No, there it is. So what I'd like you to do is turn on your calculators, and on the next 2 pages they have first how to enter data just regularly. So what you could do is you could put all of this data into list 1. And I'll do that on mine as well. So we go to Statistics, which is your Stat button. Under 1, push Enter. Now, you may have data in yours. And you have to be careful, because if you go up to a list and hit the Delete button, it deletes the list altogether. And it's like, oh, I've lost my list 1. There's ways to get it back, but it's annoying. So if you want to clear something, let's say you have 2 pieces of data in here, and you don't want to delete them individually, what you can do is go up to list 1, push the Clear button, and then point down, and it will clear that whole list. Right? But don't hit the Delete button, because then you've lost your list altogether. We can get it back, but it's kind of annoying. Okay? So what we're going to do is we're going to enter all of this data into list 1. 10, 12, 15. fun thing about this is if you type in one number wrong, all of your answers will be wrong, and you could like lose a bunch of marks. Oh, I shouldn't have talked. Oh, look at that. I didn't push enter after that 18. I gotta double check my numbers here. 10, 12. So if we put all of our data into list 1, and the first thing I would do as a check is to see I'm on number 31 right now, so that doesn't mean I put in all 30 data points. I did a quick scan and I noticed I didn't push enter in between one of them. Okay? Sometimes you can tell if you've done something off when you go to your results. So the way that we can calculate some results is, again, we can hit our stat button and then arrow over to calculate, and the first one says 1 var stats. We're going to push enter on that one. It comes up with this screen. Unless you have, if you have a TI-83, it just comes up with 1 var stats, and it doesn't come up with a screen. So if you have a TI-83, some of your calculations are going to be a little bit more difficult just because of how the screen shows up. But for your final exam, the school has all TI-84s that you're going to be able to use. So we just go down to calculate here, and after we go to calculate, this is exactly what's shown up on your TI-83, and then it goes enter, and we get this data. Did I type in anything wrong, or did you type in anything wrong? How many people have the same numbers as me? Okay, so we're going to assume that the people that have the same numbers as me typed in their numbers right, and if your number is off a little bit, you typed in something a little bit wrong.
Are we supposed to write these or these?
What we did first is wrote all of our data points. Okay? Now the annoying thing about writing all of our data points is you had to write 30 of them. Okay? What we're going to do next is look at a frequency table. How do we do a frequency table? So we're going to go back to stat and edit. And instead of writing everything in, so I'm going to go clear down with everything, I'm going to put in my frequency table. So that is my 10, 11, 12. Now the nice thing about the frequency table is, whoa. That is a lot less chance of making a mistake. I don't have my frequencies here, but was 10 3 times? Just tell me how many 11 was.
3 times.
Okay.
4 times. 3 times. 2 times. 2 times. 2 times. 5 times. 6 times.
Okay. Putting it into a frequency table, we're going to have a lot less errors, unless we did our frequency table wrong to begin with, but it's a lot easier to type in. And now when we go over to stat and calculate, we're still going to go to 1 var stat. It still comes up with this, but now in our frequency list, which was blank before, we're going to put in list 2. So that's second, I can't read the letters above here, there we go. So second number 2 is list 2, and now when we go to calculate, we notice that all of our data is exactly the same as before. It's now used that frequency. Okay? There are ways of mathematically figuring out all of these things. So first of all, a little explanation of what all these numbers are. We're not going to use all of them, but we're going to use a lot of them. X with a bar over top. That's your mean. That's your average. Okay? Do you know what this symbol means? That is a sum. It is the Greek letter sigma. That means if you added up all the numbers that you had, you would get 433. Okay? Could you do that by hand? Yes. Is this faster? Yes. If you wanted to square each of the numbers and add them up, you would get 6,489. Right now you're probably wondering, why would I want to do that? Well, in some statistical formulas that comes up. Okay? We've got the next two are standard deviations. We're going to learn about standard deviations. The one that we're going to use is the one with the Greek letter. That's a baby sigma. That's what, when a sigma is born, that's what they look like. That's what they look like when they grow up. Okay? So that is our standard deviation that we're going to use. The other standard deviation is an approximation standard deviation, but you'll look at that more if you study more statistics in university. N tells us how many things we added up, and then if we hit the arrow key down, we can see more data, and it tells us things like the smallest number was 10, the biggest number was 18, the middle number was 14.5. Well, if you have 30 data points, there is no middle number because 15 is closer to 1 and 16 is closer to 30. So that middle number was actually the average of the 15th and 16th one. And we're going to look at that when we study the median Tuesday. Quartile 1 and quartile 3, that's just the first quarter and the third quarter. So the 25th percent number, which in this case with 30 numbers would be between 7 and 8, and figure out what that number is. So between 7 and 8, apparently number 7 was a 12, number 8 was a 12, and so when they did the average, it still stayed 12. So we'll look at those kind of things. But that's coming up. So a little bit about your calculator and what you can use it for already. Okay? When you have lots of data, we can organize it in a histogram. So histogram is like the bar graph, but it has no gaps in between. So what we do is we draw a bar graph with no gaps. The width of each bar is equal to the class width on our frequency table. X is always the topic of data, Y is always the frequency. So if we are going to set this up on our calculator, and we still got our data in there from before. Okay, so go back to our calculator. So we got enter data into list 1. L1 is the midpoint of the class, L2 is the frequency. So let's see if we can get our histogram working here. So if you go second to stat plot, our stat plots are turned off. Go enter on there, turn it on. When choosing the type, choose a histogram. In our case, our frequency is in list 2. And then before we graph it, we're going to go to zoom. Whoops, push enter. Oh, no. What? Okay. Go to zoom, number 9 for zoom stat, and our histogram is appearing. Luckily, in our situation, our width already was in our window. Oh, our window is not set up correct. So we'll have to change this. We want to go to our X scale, and since the width of each of our values was 1, we want to set this as 1. And hit graph again. And now that graph, does it match up to the bar graph that we drew earlier? Very much so. So it shows the 3, 3, 4, 3, 2, 2, 2, 5, 6. So our first example here gives us a histogram. So now we know what a histogram means. The width of these histogram here is 20 each, and so the value in the middle of the histogram is what you would put as your mid-interval range. So for the age range from 0 to 20, we have 40 people, and the average of those 40 people we would say is 10 years old. Filling out the rest of this chart, so here, part of what we learn in statistics is just a statistical numeracy. It's probably one of the numeracy skills that comes up most often when you see statistics presented in the media. Right? You have to know, well, what does this mean? They show me a chart. It's supposed to help me understand what this article is about, but if I don't have the statistical numeracy to understand what's there, it's not going to help me. So one of the things that we get in statistics is just a knowledge of how the world presents data. And sometimes what articles will do is they try to present, they present data in such a way that says, if you're not smart enough to understand this, you can't comment on this. So what we want you to become is as smart as possible to understand what they're saying so you can be critical of what they're trying to present in an article and whether or not you agree or disagree with what they're trying to present. The width of each of these intervals is 20. And here is another ID word. So first we had the write down word, which we were introduced to earlier. We just had to write down the answer. The word hence. The word hence in an IB question means you have to use the data in the questions before to figure it out. So when it says hence calculate an estimate of the mean, we have to use the data in A and B, one or the other, to figure it out. So what's happening here to find the average? Well, you know the average is adding up all the ages and dividing by how many people there are. There's 270 people. But we don't know the actual ages of everybody. We just have the histogram. But we can say, well, there's 40 people between the ages of 0 and 20. So we can say there's 40 people whose average age is 10, 70 people whose average age is 30, 100 people whose average age is 50, 50 people whose average age is 70, and 10 people whose average age is 90. Adding all of those up and dividing will give us an estimate for the average age of this village. Wonderful. First video of the year. When did it turn off? Nope. So it's just like,
but it was flashing.
It's flashing. So, oh, look at that. Battery is going low. It was charging all summer, so I guess that's not enough time to charge. I don't know which one's working now. There we go. Doubly good. Number of hours per day students spent sleeping. Do you think this is accurate?
I think it's 1 hour.
1 to 3 hours. There's like 2 people that you need 3 hours of sleep. You're just so excited about a full day of math. I get you. Right? 3 to 5 hours. And then, do you know who these ones are? They're the ones that only showed up in period 2. So how many people were surveyed? You would have to add up that column to figure out how many people were there. Is this data discrete or continuous? I mean, we've got it as a number number of students, but when we think about the number of hours you sleep, is that something that's continuous or discrete? Continuous, because you can sleep. It's not like you either, oh man, I slept 1 minute past the hour and now I have to sleep for another full hour and will not possibly be able to get up. Only in hour increments. No, it is continuous. Estimate the mean hours of sleep. So here again, we use our midpoint values. So in the first one, between 1 and 3, the mid value is 2, and there's 2 people. In the second one, between 3 and 5, the mid value is 4, and there's 7 people. Yes? What if we get the bar over the x? Well, then you're not, like the x with the bar over top is the symbol for figuring out the mean. So you are trying to find the average or the mean, so that is a notation thing you would need. So here too, we could put this into our calculator. We would put in list 1 the mid values, in list 2 the frequency, and if you sketch this with your graphing calculator, and I'm going to leave that for you to try for homework, could you get that histogram? So you're going to have to go back to the instructions, and the other thing I want you to do on your own is this one, but I will give you, so you don't have to actually tally everything up, I'll give you this. I don't want to waste your time, okay? I want you to practice making your histograms, but it's in order at least, right? So it wouldn't be too bad to tally things up, but it is a lot quicker just to write down. So what I want you to do is there's space there for you to draw and sketch the histogram. Sketch it by hand. Don't even have to use a calculator to figure that out. For the one before, I'd like you to see if you can get your calculator to match up with that picture. There is a homework assignment listed for practice. We will be getting our textbooks on Tuesday. So we have to make arrangements with the library to do that, and the plan is for Tuesday. So that part, don't have to worry about yet.